So I'm going to talk about why and how data scientists get things wrong. And the subtitle of this talk might be why data scientists suck. So I've probably already broken the terms of my conduct here. But we'll see. All right. I'm going to give you 4 case studies of projects that I've been involved with and how and why they went off the rails. And I think there are general lessons for data scientists as a whole, which I'll talk through what they are. 3 main errors, we'll come back to these later, not listening to customers, right? And we'll see an example of that actually in the first one and some others. Putting computational techniques over business outcomes, right? And again, we'll see a little bit more of that. And then using the wrong methods. Now, one of the rules of presentation is you shouldn't introduce new material in the conclusion, but I'm going to do that here, right? Just because I can, right? Okay. First of our case studies is churn prediction. And if you don't know what churn is, typically for a SaaS company, it's when customers leave, right? And for a SaaS company, churn is a huge problem. There are targets. If you want to go public, you have to meet them, blah, blah, blah. In this case, the customer success department needed to reduce churn, right? They wanted to intervene and prevent it. So they came along to the data science department just before I got involved with them, right? And they asked for a model to be built. Now, here's the data set that was available. Salesforce data, so it was the account name, the location, the industry, the deal size, all those things, right? Lots and lots of information. And there was churn data for thousands of accounts, right? Going back over 10 years. Also product usage data, right? So separate from the Salesforce data. So the product was very well instrumented, and so it's who does what and when and for how long, right? All the features they were using and so on, right? Summary, lots of data and lots of features. So my first audience question, so let's see if this works. How might you solve this problem, and would you build a machine learning tool to do it? Any thoughts, any comments? I don't bite most of the time, so it's okay. Any comments?
Do classification of renewal or not.
Any else want to take a view of this? Is this worth building a machine learning model for?
The answer, it depends.
Be honest, there's different answers here, right? I'm not going to castigate.
I mean, I come from computer vision, which is completely useless to this type of problems.
All right, I'll skip on. I'm going to ask this question a number of times, so different case studies, right? So yeah, I'm not going to tear you to pieces if you get the wrong answer. Okay, so what's missing in this data is a leading economic indicator, right? So you get churn for a period of time, let's say a stable economy, then the economy has a downturn, but your model will predict a lower churn than will actually be seen, and conversely when you get recovery. So the model lacked any kind of external economic data, right? And the team that did this just weren't aware that that was an issue. I'm very dumb, right? The other thing is that the customer success team was not involved in the development of the project. That's really, really bad, right? It went off the rails very quickly and never got back on the rails, right? Because they needed to be involved all the way through. And the team didn't think about how they were going to display the information. They were, oh, we'll do this great, wonderful machine learning model and we'll do this. Well, how's it going to be consumed by customers, right? Didn't think about that. Generally speaking, customers don't want models, they want solutions, right? Now, to go back to the famous Netflix example of the recommender system, Netflix don't give a damn about recommender systems, right? What they're trying to do is get you to watch more of Netflix programming, right? So that's the ultimate goal, okay? And in this case, that's crucially important, right? So what happened here, customer success need causality. So you can't just say to them, oh, well, you know, customers in the Midwest, defense companies in the Midwest are sucking right now because they're having a bit of a downturn. How can they act on that? What can they do? They can't change the customer. They can't change them from defense to being retail or something else. That can't happen, right? You can't change the location. You can't change the deal size. So if you tell them that churn is likely to happen, all you're saying to a salesperson effectively is your life is going to suck over the next few months. And maybe you should go and find another job somewhere else, right? So it's not a good message to transmit to somebody, right? It's unactionable data. Conversely, the product usage data is actionable. Right, so there are things that you can do. If you see that customers aren't using a certain feature, you can do webinars, you can intervene, you can go and push up product usage, you can look at licensing usage, you can look at patterns of usage, all kinds of things that these guys know how to do. So realistically, when it came to it, what they were after was not a machine learning model to predict churn, but basically a model, not even a model, but a simple alerting system on low product usage. right? So we have something that the deliverable was greatly different from really, so the team had already committed to build a model, but in reality, that's what was wanted. So it's a question of not listening to customers. All right, so let's have a look at the next one. Okay, so this is a personal project. EPL is English Premier League, right? So it's football, or we say soccer here, right? So this is a personal project. Can you predict the results of EPL matches, right? So I had a go at this. I had, the Premier League was founded in about 92, 94, but you can go back about 100 years before that. Right? There's enough data to do it. So loads of data, transfer values, foreign-born players, attendance figures, blah, 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 blah. Loads of data, loads of features. So let me ask everybody that same question. Would you build a machine learning model to do this? How would you solve this problem? Anyone want to take a crack?
What's the name of this movie about American baseball?
Moneyball.
Moneyball. Is this what this is?
Yeah, I was trying to make myself rich. Well, it didn't actually work, right? So you know the answer to this already. But anybody want to take a crack at answering this? Okay, I'll answer this for you, right? So here's what I did. I used 8 different models, right? Ran them through the analysis, and frankly, the results sucked, right? I had a naive predictor, and I was comparing it against that, and I outperformed the naive predictor, but not enough, basically, to make any money on gambling. And so that, in the past, I had been part of a gambling syndicate, right, that did actually make some money. Right, so this time, but that was in the UK, not here. So anyway, when I talked to people, I said, well, how can I make this better? What can I do? I said to a number of data scientists, what should I do here? And they said, well, have you tried more models? Well, I tried 8 different models, right? Trying more models is probably not going to work, right? It's not an effective thing. And everybody said, try an ensemble model, right? So think about the ensemble model, right? So I've just told you that my results sucked. But what you're saying is we're going to add together a couple of models that suck to make one bigger model that sucks slightly less, right? So, I mean, maybe it would have worked, but none of the models actually gave me any particularly good results anywhere, right? So an ensemble model isn't going to work. Very, very few people, disappointingly, told me to go and get more data, right? Now, it would actually have been possible to go back and define extra fields that I didn't define. I did do some unsupervised learning. That didn't give me anything either. But yes, more data, I think, actually would have made a difference here, right? And it would have helped me boost. The other thing that nobody at all, other than me, suggested was killing the project. Killing the project is probably because there's too much randomness underneath, right, to really produce an effective model, right? And the proof of this almost is if you turn on the TV and look at any sporting event, how many people lead with our computer models are predicting a 3-2 or whatever the victory is? Nobody does it, right? Now, you think there that if this was the case, if these models actually worked very successfully, then you would expect that to be the case, right? So it's a kind of an existence proof. But let me ask people, how many people in this room have been part of a data science project that was cancelled because the underlying data was just too random for models to work? I see no.
Yeah.
Well,
Yeah. But yeah. I've had it before.
anybody else?
Isn't randomness good for this? Isn't that the idea that?
Well, if it's randomness, it's predictability, right? And if you have a truly random system, you can't predict it, right?
It's not doesn't have a distribution that can predict.
There's no underlying logic, right? For you to. So look, think about that. Think about, we've got 2 people in the room who've experienced a project that they've cancelled, right? In my case, I cancelled, right? Don't you think that figure should be a bit higher? Right? So I'm asking you guys to think of the projects that you've worked on. Do you think around this room that there should be more hands going up, people saying, yeah, our underlying system is just a little bit too random for this to work? So have a think about that. Okay, so let's go to the next one.
Can I ask a question? On the previous slide. I think I remember what ensemble method is, but can you refresh my
Yeah, so typically you take like a couple of models, right? So I said GLM, CNN, SVM, whatever. Right, now what it might be that under certain conditions, some of these results gave okay results, and other conditions they gave poor results. The idea would be to kind of bolt these 2 models together and say, over this range, we're going to use this model. and over this range we're going to use that model, or even just add the results together somehow, or somehow combine them in different ways.
Yeah. My memory was that ensemble means that you take the error of the first model and you apply a second model to the error and you chain them this way, model on the error, and then you get another error and you get a third model on top.
Yeah, you can do that. You could.
That's boosting. I see. So that's good to know. Thanks.
Yes, so there's different ways of combining the models, but bear in mind, each time you bring another model, it's a computational cost as well. And that's one of the reasons why the Netflix solution, the prize winners, was never implemented, because the cost was too high in computational time for the benefit. Okay, sales prospecting. There's a little bit of a sales theme running through this, right? It's kind of, you know. Okay, so in this case, the sales and marketing team came to me and they said, we need to improve our prospecting process, right? We need to be able to focus our team and where they're making their calls. Can you help us? So we know Salesforce data, which is location, industry, all kinds of details about company turnover, blah, 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 all those things. We have a lot of lead generation data. We have enough data and features, and the sales and marketing team sitting in the room, well, virtually because it was post-pandemic, right? But sitting in the room guiding this, right? So there's customer involvement all the way along, right? Enough data and enough features. My two questions here. Would you build a machine learning model to do it? How might you solve this problem? You want to take a crack?
I think you might run into the whole searching the light post problem here, because you're only got data for where they've tried to sell before. So you won't have data where they haven't tried. So I don't know which key question I'm answering.
That's fine. It's interactive, is it? Okay. Anybody else want to have a crack at an answer? Okay. Actually, I thought a machine learning model was actually potentially a great solution here, right? I thought this is a really great thing to do. So I had somebody on my team do it, and this is what happened, right? They built the machine learning model, right? But the problem they ran into, it's not like I think, is it search post or lamp post problem? Yeah, it's not that. But what we found is that there were problems with the data, right? So the Salesforce data was missing data. One of the key fields actually was a categorical variable that should have had about 30 different variables, numbers in it, or values in it. It actually had 700 because things had been mislabeled, right, in Salesforce. Too much mistaken diversity, wrong inconsistent data, et cetera, right? So the model didn't converge. Right, so the data scientists working on this put more and more computing power into it, and it didn't work at all. Right, so what would you do in that circumstance?
Abandon the project.
I know, look, I'm kind of the harbinger of death here, aren't I? Yeah, I killed the project, right? And the marketing, the CMO was really, really angry, but the CEO told me I did the right thing, right? To kill, because there was just no realistic prospect of success. So one of the things I do see with data scientists doing, right, and I got some real pushback from this, is saying just carry on, right? But there's no point. At some point you look at a project and it's just not going to work, right? So it's time to kill it and move on to the next thing. Okay, so this is, all the other ones have been fairly direct with what happened. This one I've had to change the details a bit because it would identify the company too much. So, but this is the closest I could get it, right? So it's responses to fraud. It wasn't really fraud, it was something else, but it's close enough to get you there. So the problem was we were trying to decide, are businesses who suffer fraud likely to suffer more fraud or less fraud in the future? Right, so there's two arguments. One is that if you suffer fraud, you're going to improve your own internal processes, which will make you less vulnerable in the future. The other one is that you're a bit slack, right, which is why you got hit by fraud. Therefore, you'll be slack in the future. Therefore, you'll have more fraud in the future, right? So two competing arguments, right? And the goal was to decide on the face of it, which of those two arguments was actually correct. So actually, were companies who suffered a fraud more or less vulnerable, right? So the data set here was complete in the sense we didn't need any external economic indicators. There were loads and loads of business data. We had the fraud prosecution results, right? We knew all of that. Data complete, all the data and features enough, millions of data points, it's all fine. And the customer, in this case, marketing, was fully engaged. So let me ask my question. Anybody want to take a crack? Would you build a machine learning model? How do you tackle this problem?
Probably.
Who would,
I mean, if it's, you're saying millions of businesses?
millions of data
Oh,
points.
you have lots of data.
And the data is high quality data.
Yes, no data quality problems at all. This project actually worked, right, unlike the others. So I actually worked.
Is it a panel data set?
Sorry?
The panel like longitudinal, so you get each individual, like business each at point.
You know all the businesses at different points in time and you know whether they were fraud free or not. Right. So as I said, it's not fraud, it's actually something else, but the equivalent of that had. Right.
Yeah, you could do like a hazard model.
Anybody else want to comment? Because you're going to know the result of this. Anybody else want to comment?
Yeah, it's the same, right? Like that's like if you have millions of observations, probably it's not millions of businesses, it's millions of.
It is millions of businesses.
Oh, it is.
It was 12 million plus businesses.
Oh, okay.
Okay, so I'll answer my own question, right? So there was a push from the team to do it, right? My team, a few people wanted to do machine learning, and I said no. So that we were not going to use machine learning for this. What we did is difference in differences, right? And it's a quasi-experimental technique, and the project actually succeeded, and it succeeded very well, right? So we got the publication out of it, we actually took it to Congress, and we did a whole bunch of other things with the results. Okay, so let's go back to the three main sources of error, right? Not listening to customers, right? Huge source of problem, right? That happens when the customer isn't in the room and you're off doing your own thing and thinking all about, basically, always this, XG boost or something, right? Right, but not talking to the customers, figuring out what they want. Computational techniques over business outcomes. When you sit down in your groups and you discuss, how often do you discuss what the customer wants and how much do you discuss the computational techniques? And at a guess, you're there discussing techniques way more than the business, right? That'd be my guess. And then lastly, using the wrong methods, right? Okay, so maybe the wrong model, the wrong whatever. Okay, so how can you protect yourself against this, right? So listen to your colleagues, right? Sales reps, I know they don't have PhDs and they don't have master's degrees and all those things, right? But they have years and years of experience and they can sell and you can't, right? So go and listen to them, right? And listen to the relationships and what they want. Product, look, let's be honest, right? We're all adults here. Product are a variable quality, right? The product teams, right? Some good, some bad. If you get a good product person, they are a proxy for the customer, right? But sometimes basically they're just project managers. So just be careful about what you've got in terms of the way of a product person. What's the true business goal? Right, back to that Netflix example and back to my example about the churn model. What's really wanted here? And they might tell you that they want a model because that's sexy and it's wonderful and all the rest of it, right? But really, is that what they want, right? So there's usually an underlying problem and the product people should help you do that. But often they don't, right? So you can't rely on them. Alternative approaches, and we've talked through this, right? So it's not just using difference and differences or machine learning or whatever, right? There are other cases. So I had a problem where I needed to go and get a whole set of data labeled, and people were saying, well, let's go and do a machine learning problem and just label it, right? And I said, no, I had a college student and got them to go and basically label the data by hand, and it was cheaper to do that than machine learning. Right, so I'm asking you to think a bit more flexibly about, not everything is a machine learning problem, not everything, you can actually pay people to go out and do stuff like this. And you can go out to low-cost countries and have people do it. And then the last thing here is what's your project kill criteria? So think for the projects that you're working on, when would you kill the project, right? And I know I'm like a bit happy to kill projects, right, and all the rest of it, but for you guys, think about this. What would cause you as a manager or whatever it is to go and stop your project and allocate the resources elsewhere? So you should know what that is, and at least certainly the person running the project should know what that is. So my final thought is to be less wrong, think more like a business person and less like a data scientist. So that's it, folks. Thank you all very much.
Can I ask why a difference in difference is not a machine learning approach?
I think, so maybe this is just me. I just think of machine learning as being a different category of things.
Okay.
Right?
Yeah.
So it might just be semantics. You think it's machine learning. I don't. It's fine. It doesn't really matter, does it?
Okay. Yeah, I mean, yeah. Yes. It seems like a machine learning solution was the right.
Yeah. Well, actually, one of the things that we have, right, and a company I work for needs to show more machine learning, more stuff. So if you're telling me that difference in difference counts as machine learning, I'm going to count it, right? Because we need it for our marketing department.
Yeah, absolutely. It's AI. Say whatever, right?
How does difference in difference work, roughly speaking?
Talk to him.
So the idea is, you have a quasi-experimental where you have a control group that looks similar to your treatment. And you want them to have like linear trends. They don't have to be exactly the same. And then the underlying assumption is that post-treatment, the trend would happen, they would follow the same. But what you do is you measure the difference pre-treatment, then you measure the post-treatment difference, and then you take the difference of those two differences. And that difference is the treatment effect or the intervention.
It's a cool method.
Yeah, synthetic controls is a little similar to it. It doesn't have as much like the underlying parallel trends assumption, but again, and you don't need to have as good of a lookalike treatment group. So like I think it was Card and
Kruger.
Yeah, they use what they do is they look at differences in minimum wage going up in New Jersey, and they used a budding town that's in Pennsylvania. So they should look almost identical economically. And what was the effect of increasing minimum wage on unemployment? And they didn't measure, they didn't find anything. Yeah. And there's another one, I can't think of the other authors, Marion Boat.
I was thinking of John Snow in 1854.
Oh, which one?
The cholera.
Oh, no. Oh,
It's one of the-
Analysis example. Yeah.
Yeah, I just read that in the Book of Why. I think it was that book?
Yeah. Why the kill? Like, why not? Because I feel like I'm just thinking about the one that like, we killed one. We didn't kill it. We like changed its trajectory a little bit.
So the EPL one, I might come back to that, right? I still fantasize about, a yacht in the Mediterranean, right? And going back to my gambling syndicate. So it might be possible to do something, right? It just needs to be recast. But I needed to walk away from that for a period of time.
Right.
That was a personal project, right? So it's easy to do. The other project that I killed, which is the Salesforce one, and but the prospecting. Look, realistically, to fix the data would have required a great deal of effort, and there was no money to do it, right? So the data scientists around the table, if I said to you, well, you're going to spend the next month fixing Salesforce data errors, right? I think there'd be a massive revolt, right? So it's not right. And even if that data, those things were fixed, there were still other problems as well. So again, it's, is there a realistic, like a legal test? Is there a realistic prospect of success? And in this case, I just didn't think that there was at all. Right, so Paul, I mean, it was easy for me, right, being the boss, right, I could do it. But, for other people as well, I recognize this kind of stuff is quite hard to do. But for you, for your own survivability, right, if you're working on a project and you kind of have doubts, it's time to start looking for another job. I mean, better to look for another job before you're kicked out, right, because somebody kills the project for you, right? So you should always be aware, right, about the realistic prospect of success.
So with your EPL model, do you just use, did you use any individual player information, of lags of how they've been performing the last 3 games,
No, so that's good. So you can do that, right? But you pay an arm and a leg for that data, right? It is available. And I, being a cheapskate, I just said I would use data I could get.
Web scrape.
Oh my God, I love that.
But actually, one thing I did find, right? So there's a home team effect, right? And there's always a thought, right, in any kind of competitive sport, right, that the home team has an advantage, and you clearly see that during the pandemic, the home team effect just went away completely, right? The goal difference just dropped to 0, and then you go back in and you look before that and you look after, and it's like half a goal per game, right? It's the home team effect. It's absolutely crystal clear. And I found that, but I never published it. And I saw somebody at an academic institution published it. And I thought, damn, if I'd have just had a bit more faith in myself, paper, but never did. But yeah, for that kind of stuff, right? Getting the data is difficult, right? And I said airily you can go back 100 years, which you can, right? But there's no foreign-born data set beyond, right? I think some people started it in about 2000. Transfer values, well, maybe that people started recording that in the 80s, right? You go back to the 1950s, how many, right? So there's a question. Some of this data is available. I'm gonna probably at some time I'm gonna have another go at this, right? Just out of interest to see if I can actually do any better. But yeah, I mean, at some point you do need to kill projects.
I was thinking on that I'm really curious about is like you have all these like tabular features, like numeric features, categorical features. Like, have you ever thought about like translating that into text and then trying to like transfer learn from the language models, like, you know, to see the language model, like with the representations it has from all that, if that would help it predict it, like.
I don't know, to be honest. Right, I'm rethinking some of this. I'm also rethinking things about promotion and relegation, which goes on in the EPL, and capturing that. But I hadn't thought about using text stuff at all.
I'd be curious how that would intersect with the causal inference stuff. I think trying to put those two together would be really something.
Yeah, it could just be that sporting events are just too random for worthwhile prediction. But there is a talk that higher scoring games like basketball and other things, right, they might be easier to predict than most scoring games.
There's a really interesting, what's Nate Silver's outfit?
538.
Yeah, they did one on their Premier League predictions, and they note how, I think they stopped giving guesses at like 5 minutes
Right.
at the end, because they say it's so random that there's, you know, because one goal can change so much.
Yeah.
So that was what they really discussed a lot, is that you can make predictions as much as you want, but because it's such a low scoring game, that one event can have such a large effect.
Yeah.
They also talked about like the importance of which variables you're using. So is possession percent on its own is not very effective. And we saw that with Japan versus Germany, I think, in the World Cup, where it's actually possession in the defensive third or offensive third, it's far more predictive. So it's also just like defining these metrics.
A subset of the soccer problem is like the penalty kicks. The statistics of the goalie, where do they jump, left or right? The statistics of the shooter shoots left or right, and they both know the other guy's statistic, and the question is, how do they do it? You know?
But he knows, they knows the NFL. And now they do, like, after, like, if you watch the penalty kicks, like, this is one during the game, they'll go to the manager and they'll start talking, figure out which way they're gonna go.
Yeah, depressingly, actually, one of the things I found is that the clubs with the most money win the most often, right? Which is you know, hardly a shocking result, right?
Tell it to Chelsea.
Yeah, no. But it is a depressing result, but it's there.